my podcast. In this episode, I have a special guest. He's joining me from Perth in Western Australia, Scott Gover. Welcome to this episode of the podcast, Scott.
Yes, Siamak, thanks for having me.
Excellent. Well, Scott, as you may know, I ask a question about my guest's career. That's normally what I start with. If you want to tell us about your background, your career, where did you start? How did you end up in tailings engineering? We can then start asking the future questions from there.
Yeah, no problem. So I'm originally from South Africa. You may have heard from the accent. So born and bred around Johannesburg. I did undergraduate in civil engineering at the University of Witwatersrand, and then a couple of years later, I did postgraduate at Pretoria University, which ended in a master's thesis. And my master's thesis was in reliability-based slope stability analysis of tailings dams. So it was my first real introduction into risk and reliability and uncertainties, and I've pretty much been living and breathing risk ever since then. And I think most of the first 2/3 of my career was experience in Africa, where every cent we spent needs to be justified for our clients. It's a very different market. I led the tailings division in Golder at the time for Africa for about 5 years, and then in the beginning of 2021, I relocated with my family to Perth in Australia. And since being here, just really focusing on ITR projects, engineer of record stewardship programs, just in compliance work, and then a lot of risk work, risk studies, including a bunch of QRAs and all sorts of risk assessments in different shapes and sizes. And then extending from that is I'm looking to take on a new role within the company where I can provide a little bit more focused risk support on projects for the region. So yeah, that's pretty much me.
Okay, no, great, excellent. Well, as again you may know, I have worked for Golder in the past, and I know how like it was a great experience from my side. Like the practical, the learning aspect of everything. So yeah, I think it's really good. The question I wanted to ask you, so you mentioned about your background and the work you've done in risk reliability, but maybe before discussing the risk assessments and maybe risk-based designs in tailings management, tailings engineering, so what do you think are some of the dangers of risk quantifications? If you can tell us about that, that would be great.
Yeah, no, that's a good question to kick us off. And it is always a topic of debate. So, and I think I have my own opinion on this. Obviously, it's based on my experience of working in different regions, and it's solely my experience. But there's definitely is dangers in doing risk assessments and risk quantification if you misuse it. So I think to name a few, one is some people might say it's an attempt to define it as a scientific concept, which it may or may not be. There's questions about whether risk assessments and risk quantification is repeatable between various practitioners and methodologies. Um, there's also the propensity to use thresholds, to make decisions on not to control risks, which may not be the appropriate thing to do. And then also in Australia, some of our regulations don't actually prescribe risk quantification at all. So it really is it's an interesting place to work, and I think it's important to have an understanding of all of these. And as far as it being a perfect science, it's not, but it's necessary. I think industries such as aerospace and nuclear, they have to define their system and their system components and measure the probability of failure each of those components. it's necessary in our insurance for our companies, and even for things like predicting the weather. We need risk. And the benefit in some of those industries is that, in aerospace and in nuclear, they can vigorously test system components to failure and measure, what is the frequency that this specific component might fail, and use that to define the system reliability. And things like in the insurance industries and the weather industries, they get immediate feedback.
Yeah.
They predict the rain tomorrow. They get feedback the next day, so they're able to practice and refine their art. Whereas I think tailings relatively get very little feedback on whether we predict something will fail or not. So there are very rare events of these facilities failing, and they're very severe consequences. So it is really the difference in the availability of the data that we have. We don't have the luxury of some of those industries, and we can't test every system component within our tailings storage facility within the system itself, and we just don't get that feedback. So we make things a little more difficult as well, because we have to rely on things like engineering judgment, and that brings its own challenges with it. But I think it's more about how we become consistent in doing that. And I think that's part of it. So one of the things, if you look in our safety case guideline in Australia, they have a statement where they say, two independent risk experts assessing the same circumstances or situation never come up with the same answer,
Yeah.
unless they use deliberately identical assumptions and processes, in which case the assessment is not independent.
Yeah.
So it is a challenge that we have to deal with. But I think if we can work on making our basis of assessment more consistent, and the methodology that we're using more consistent, more transparent, then we can get better at doing this. And I think we can develop tools to help us elicit an engineering judgment in a better and a more transparent way and a more consistent way. Because, any tool we use in engineering can be misused. And it's about understanding the limitations and being transparent and being diligent in how you use these things. And that's rather, I'm, on a path to try and improve the way we do these things, and be consistent, be transparent, rather than just solve it. Because in engineering, I think it's important to have as many tools as possible as we can. Risk is not a replacement for deterministic based engineering. It is a supplementary tool to help us with that decision making. And on even on the topic of the decision making, the risk of using a threshold to make decisions to not do anything, I don't really see that happen. I think in tailings we never stop. We never really do nothing. We're always looking to control risk continuously. So I don't really see that as a factor. And we have similar thresholds in our deterministic analysis. We designed this a threshold of a factor of safety of 1.5, and sometimes because we achieve more than 1.5, does that mean that we stop there? There's still more that we're going to do, and that's just about using those tools responsibly. And in today's times, with particularly the clients that we're working with, we have layers of protection in independent technical reviews, that it's actually very easy to prevent that from happening. But it's important that people know that we don't aim at a threshold, at a target, and when we reach below that, we stop, because that's obviously a misuse of some of our risk tools, and it's against what our regulations point out. There are regulations, excuse me, in Australia that don't prescribe risk quantification at all for what we do, and I think in many instances you don't need to quantify risk to identify what the reasonably practical control is.
Yeah.
Sometimes it's not necessary, and I think that's kind of leading me into some other ideas, in that I'm believing that tailings is perhaps maybe a little bit more different to some other civil engineering practices and infrastructure. So that's something I'm happy to talk about, and also
Yeah.
when it comes to our regulations I try not to get too wound up into legal interpretations and
Mm.
my interpretation of our regulations and our legal obligations is primarily that we show due diligence and that we're not
Yeah.
negligent in what we do. And we need to, be achieve at least the current state of practice. And perhaps one day if we get better at how we use risk quantification and risk assessments and risk tools, then those will actually be a part of our current state of practice. And we'd actually be needing to use those as supplementary tools in things we do every day. So I see this as part of our future, really. Yeah.
Yeah. Yeah. No, I think that's quite important, Scott. You kind of, compared at the same time compared like the Australian regulation versus maybe other parts of the world, also comparing these the risk and reliability in the industry that we are in, civil engineering, with other industries. But I also wanted to ask you about what differences you see in terms of the risk practice between the tailings, especially compared with other civil engineering disciplines.
Yeah. Um, yeah, and this is something I've been thinking about. I just think tailings is a lot more complex. It is a system. It's not a very one-dimensional infrastructure. It's a system, and there's an additional level of uncertainty in everything we do. So I think it's far more complex than, for example, just a building, a high-rise building, or perhaps even a water dam. And I think at the same time, there's additional layers of uncertainties. We classify uncertainties into three different types, being natural variability, model uncertainties, and decision uncertainties.
Mhm.
Um, and I can talk a bit about that, but on the point of it being a little bit more complex is I think we're not quite a nuclear facility, I
Yeah.
would say, or aerospace engineering, but I think we're somewhere in between that and maybe a road or a building. And I think that's because the decisions we make on controls and spending money, those have an impact on a company's bottom line. This isn't just a piece of infrastructure that maybe, for example, could be managed by the municipal department, but it's part of a company's annual turnover in terms of producing, mining, making a profit, meeting their shareholder demands. So
Mhm.
it's important that we understand that decisions we make on spending money have an impact to how the company will operate. So, in terms of an example, if we're dealing with a capacity issue or a water balance issue on a tailings facility, we can very easily say, well, let's increase the slurry concentration, let's thicken up the tailings or something to
Yeah.
improve this. Now that's going to change settling velocities in the pipes. And whether the pumps and the piping system can handle that, we need to go out and we need to speak to the plant team and figure out whether they can do that. And whether they have to increase the pump capacity. So there's knock-on effects on that. And then it also will potentially impact our beach slopes.
Yeah.
And if, for example, it steepens our beach slopes, we maybe use up our operational freeboard quicker and actually have another, do the reverse effect. And we've got more of an issue with capacity than we had before. So it's really complex and everything is interconnected. And that's why I think one of the benefits of working in a company like WSP is that we have all of those services under one roof. And if I have got that question about the settling velocity, I can go and find the person. And when I want to check the water balance impacts, I can go and find that person and sit with them and we can figure that out. Um, and on top of that, there's this idea of uncertainties, you know, perhaps I can sort of touch on that. And, I think we've got similar, for instance, like natural variability. So the
Yeah.
natural variability of our foundation is similar to what a team designing a high-rise building will be dealing with. But when it comes to things like model uncertainty, I think we're just ahead. We're a bit more challenging there. We've got the way we deposit tailings and the way it settles out it ends up in a state that's potentially liquefiable, and it's really hard for us to even test that because we can't take undisturbed samples out of the dam, and so we have to take disturbed samples. And then, I think you're going to be talking to Dave Reed in a future episode, and he can talk you through some of these things about how difficult it is to try and mimic the conditions that are on the site, laboratory, to understand the potential for this material to behave in a very complex way.
Yeah.
Um, and that's just one aspect I think we deal with. The other one is the knowledge uncertainty, which is often quite hard to characterize. But because it's such a complex system, and there's so many moving parts, I think as an example, if your dam safety manager recommends a $200,000 standby pump be put onto the tailings dam to reduce what might be like a 10 to the minus 8 overtopping risk on your dam, right? He sees that as the appropriate control. And your legal team's going to support that because they want to eliminate all hazards to so far as reasonably practicable. So they're going to support that. But your risk manager could be arguing that there's actually much higher risks than this 10 to the minus 8, risk in their plant building, and the money that they should be spending should be put there. Or the health and safety manager isn't happy because the exposure of his team having to work near water in servicing this additional pump is a burden to his team. And for example, in Africa, you might decrease your premium because you've reduced the probability of failure due to overtopping, but your premium goes up because you've got this infrastructure on site that's a risk of theft.
Yeah.
In Africa, so the premium ends up going up. So it really, really is a very interconnected and complicated system, and it takes a lot of engagement to kind of get around some of these decisions.
Yeah.
In fact, we were conducting some internal training within WSP on legal obligations and LARP and SFARP, and it actually developed into a very interesting discussion on when are we actually required to demonstrate a LARP for our facilities? And it was a difficult question to ask because, as I said earlier, we never really stop working. So if we've said the facilities are LARP, but then we proceed to carry on reducing risks, were we really accurate in that? We don't say I'm done, it's a LARP, I'll see you at next year's review. We're continually working on reducing risk on our facilities with our stewardship programs. And it
Yeah.
comes back to that idea of, would we use the threshold to say no? And I don't think we ever would, because, do nothing has only ever come up, in my experience, as a closure option. And
Yeah.
that took a lot of reasoning. We still haven't selected that as a potential option, but it might. And if it did, we'd have all the due diligence to prove why it's the most reasonably practicable option. So yeah, it makes it a very interesting space to be working in.
Correct. Yeah. No, exactly. And the way you describe it, yeah, it's like a very interesting area, like a lot of overlap in between like various different
Mm.
things, and like a lot of moving parts as you mentioned, and you try to fix something but you're affecting something else. That's always a challenge. Also, you mentioned about like the tools that we have, like this risk quantification, risk assessment. I just wanted to ask, what do you think can be done to improve the use of these tools, the risk quantification, in the tailings practice?
Yeah, no, I think I touched on. I think that the key things is about getting consistency and
Yeah.
reliability and transparency into that process, and finding ways to improve how we elicit engineering judgment and how we use that, and then that being defensible and transparent in itself. Um, and I've actually just finished writing a paper for this year's Tailings and Mine Waste Conference in Canada with a colleague on a tool that we've been working on to help us
Mhm.
in that process, because it's something that we're doing very often. And we want to make sure that we have as much consistency and transparency in the process. And so that'll come out later this year. But then also, I think we need to start working with uncertainty every day. So one of the things I often see is that even in people's risk training workshops is they say, risk assessment is, or dealing with uncertainty is something we turn to when data is sparse or when data is incomplete.
Mm.
So there's this conception or misconception that, when we don't have data to do a deterministic analysis, we have to do a risk-based analysis. And in my opinion, I think it's something we should be using all the time. We should be using the tools to measure, quantify, and demonstrate how uncertainty propagates through our issue every day. So even if we have a lot of data, we should be using our tools to show that our uncertainty is low. And because of that, these are the decisions that can be made. And I think that takes practice. So, and there's a couple simple things. I think, as an example, the coefficient of variation, I think, is something that's very underused. Uh, and it's so simple. It's just the standard deviation divided by the mean of your parameter. So it's a dimensionless unit, as look at it as a percentage. And if you get into the habit of using that when you're presenting data, you start seeing the trends in that data of, when I deal with a friction angle of a sand, it typically ranges always between 5% and 15%. And so as you develop and you understand those trends, and there's a lot of this data is published, when you see a coefficient of variation of 5%, you know that you've got a very low uncertainty in your strength parameter. But when you see one at 15, you know it's very high. And when you see one at 30%, you think something must be seriously wrong in the way we've tested this material. So it's something to just, such a simple tool, get the hang of it, and you will learn so much about variability in materials.
Mm.
Another one is just, take the time to learn a little bit about distribution basics, even just starting with a normal distribution and what does one standard deviation, two standard deviations, three standard deviations look like. There's the 3 sigma rule, which is 99.74% of all values fall between 3 standard deviations of your mean, which is very useful. And knowing that 60% of values will fall between 1 standard deviation either side of a mean. And when we start kind of combining that with the way we look at our analysis that we're doing, and we say, instead of going, I'm going to do a limit state and just choose the worst case parameters, let's choose the expected parameter and then go, well, what does 1 standard deviation higher and lower do? And what does 3 standard deviations higher and lower do? And what does that look like in the distribution of our possible results? And start looking at the potential results as a distribution in itself. In other words, how error propagates through our analysis isn't really not difficult, and I think has a potential to impact the way we make decisions, um, and help us support all the deterministic tools that we're not going to do away with. Will help us support that and help us make decisions in a much better way, and to be honest, to be more defensible than what we were in to start.
Yeah, yeah. No, that's very interesting, and I think some of these topics, as you mentioned, Scott, I think we probably need a full episode to really dig in and be able to like come up to some sort of conclusion. So and the one thing I wanted also to ask you about, so the conferences in Tallinn, so this is something that I want to promote to my audience. So you mentioned the one in Canada. I think there's one coming in Brisbane, Australia next month. If you want to talk about that as well.
I think they're absolutely essential for, essentially, it's the start of where current practice gets set, right?
Yeah.
It's going to sit and listen to other like-minded people who are passionate about what they do, and hearing what other people are doing and what we can add back to the industry. And then, as a company, if you can send as many juniors as you can there, it's that experience, and even if you take nothing technical away, it's about walking away going, I also want to contribute.
Yeah.
Is what I think is most important.
Yeah. Excellent. Um, as my final question, Scott, I want to go back to the question I asked at the beginning about your career in civil engineering and tailings engineering. And it's something I ask every one of my guests on this podcast, and that's about the highlights in your career. What do you think was the highlight of your career, and why?
Yeah. Okay. It's an interesting question. I think for me, I'm someone who really loves learning. Um, I constantly have something that I'm busy with as a home project, or have been for years, whether it's learning how to solve a Rubik's Cube or build a dirt bike engine. I love to learn new things. And I think risk has been that for me. It's been a never-ending learning journey. So,
Mm,
from doing my master's dissertation, um, to spending social events talking about risk with Pete Chapman, who you heard on your podcast previously, uh, debating risk assessments with people at the hotel bar at 2 o'clock in the morning of a conference.
yeah.
You can learn a hell of a lot doing that. Um, I think I got to present. Andy Fury asked me to present at his AGS conference on uncertainty. That was, one of my highlights. And then even things like talking on a podcast. All of these
Mm.
are things that come with the journey about learning something. Yeah,
Excellent. No, that's great. And I think like sharing the knowledge is very important. I think especially in tailings engineering, from my observation, having junior engineers, getting into this industry and learning and developing, and that comes with like more open share of knowledge. So that's quite important. Very
yeah.
good. Excellent. All right. Thanks a lot, Scott, for your time. And thanks to our audience for watching or listening to this episode. I'll catch up with everyone in the next episode. Thank you very much.
Thank you. Cheers.